Guess what, my year one Whipper Mathers? We're in for a treat. We're going to dive into decimals. So basically, when you were little, your teachers just told you about whole numbers because, whoa, that was enough already. Learning to count was hard. If they told you that there are infinite numbers in between each of those numbers, if you break them into little pieces, your poor little kid brain would have popped right out of your head. So now we're going to just take a walk down memory lane, some place value stuff to kind of get you in the right state of mind for what we're going to dive into this week. Remember in our place value grid how we could label each place and period if we have a hard time keeping track of something nitpicky like that? Well, here's my place value grid. We're in a base 10 system. And what that means is whenever you have 10 of something, you can bump over to the next place value. So for example, if I gave you 10 $1 bills, you would have a $10 bill. If I gave you 10 $10 bills, well, you would have 100. If I gave you 10 $100 bills, you would have 1,000. And I'm not going to go down the whole place value chart because you'll fall asleep. But the bottom line is when we move next door to the left like this on the number line, then we are getting bigger by powers of 10. Well, when we move to the right on the number line, it's dividing by powers of 10. So if you split $1,000 between 10 people, everybody would get 100. If you split $100 between 10 people, everyone would get a $10 bill. And finally, if you had a $10 bill and you split it between every 10 people, everyone would get $1. Well, what would happen if we took that $1 and we split it between 10 people? We can do that. It would just be an amount less than 1. So for a second, I want you to get greedy. I want you to think about $1 bill. If we were going to split that $1 bill up evenly into 10 equal pieces, what kind of coin would that make? If you were thinking dime, you got it. It's like dimes. A dime is a tenth of a dollar. Hence why if we had a 1 and we divided it in 10, we would call it a tenth. And it lives right next door to the decimal point. And then think about that dime. What if we took that dime and we split it up between 10 people? So take a dime, divide it by 10, and think of what coin you would get. What takes 10 to make a dime? A penny. And so a penny is 1/100th of a dollar. It takes 100 of them to make one whole. One misconception that kids have is they think 100th is bigger than a tenth because they hear that word 100 and their little kid brain gets excited. But actually, the further you move down the way from the decimal, the smaller the number gets because we're always dividing each place value by 10. And when you get into your upper grades, you'll go even further. So that is the gist of it. I want to show you how we'll read these numbers. So let's say that I had 3.25. I would read that number, the whole number part first, and then when I see the decimal, I would read the word and. From here on out, the only thing that says and is that decimal point. And then you look to see how much you have left over. I've got 25. 25 what's? Look where the number ends. It ends in the hundredths place, the pennies. So I would read the number like this. 3 and 25 hundredths. The biggest thing to look for is where does my number end? That's the place that I'm going to read when I'm reading this number out loud. And then the last thing we're going to do real quick, I know this is a long one, we're going to look at a model real quickly. So let's say that I have one rectangle and that rectangle is going to be worth one whole. Where's my model? There it is. Oh my God. So let's take a look at this model. My video got funky, so I'm back. I was gone, but I'm back. Okay, pretend that one rectangle is one whole. If that whole is broken into that many equal pieces, I count them, and it turns out there's 10 equal pieces. So each of those sticks or longs is like a tenth or a dime. So altogether, I have four what? 4 tenths. And remember, the tenths live right next door to the decimal point. So my number would look something like this: 0 and 4 tenths. Let's look at just one more model, and then I'll be done, I promise. Let's say that we have this rectangle, and it is equal to 1 whole. When you were younger, you were used to that equaling 100. In this case, we're going to say it equals 1 broken into 100 pieces. So it's a little bit of a mind shift there. So here I've got my 1 whole flat. I've broken it into 100 pieces, and I have 3 of them. Look at this common mistake. Some kids will just put 0.3. Can you see what's wrong with that? It's not 3, because that is 3 tenths. And we do not have 3 tenths. We do not have 3 dimes. We only have 3 pennies. So look how I'm shading 3 dimes, and see if you can see the difference between those. 3 dimes is 30 cents, not 3 cents. And so what can I do to get the 3 in the hundredths place? I can add a very, very important place holding 0 and bump my 3 over to its place value that is correct for this model, 3 in the hundredths place. And I know those are hundredths because it takes 100 of them to make the whole. What? Are decimals cool or what? I think you're actually going to think so, okay? Just trust me. Trust me on this one. Okay, we're going to have fun this week, I promise you that.